Have you ever really stopped to think about the software that powers, well, pretty much everything? I mean, from your Android phone to the huge servers that run the cloud, the Linux kernel is almost always at the heart of it. So, how on earth do you test something so massive, so important, to make sure it doesn't, break? Let's dive in. So, here's what we're going to cover. We'll start with the sheer scale of the challenge. We're talking billions of devices. Then we'll look at the whole universe of testing tools developers have. After that, we're going to zero in on the two main pillars, Kselftest and KUnit, before we see how it all works in the real world. Okay, first things first, let's just try to wrap our heads around the scale of this problem. I mean, it's one thing to test a simple app you're building, right? But the Linux kernel, that is a completely different beast. To put a number on it, there are well over 1 billion active instances of the Linux kernel running right now. Yeah, you heard that right, 1 billion. That's on your phone, probably your TV, the servers delivering this to you right now, and that number is just exploding with the Internet of Things. So how do you manage that? A single tiny bug, what they call a regression, where a new change breaks something that used to work just fine. It could affect millions, maybe even billions of people. Seriously, how do these developers sleep at night? Well, the answer is a really deep, multi-layered, and constantly evolving approach to testing. So how do they meet this challenge? It's not about finding one magic tool that solves everything. Nope. Instead, the kernel community relies on a whole universe of different testing tools and strategies, and each one is designed to find very different kinds of problems. You've got dynamic analysis tools like Kselftest, which are like little detectives looking for memory errors while the kernel is actually running. Then there are static analysis tools like Sparse that scan the source code for potential problems before it's even compiled. And you've even got code coverage tools to see which parts of the kernel are actually getting tested. It really is a whole ecosystem. But for our purposes today, we're going to zoom in on the two big ones, the main frameworks developers use to actually write and run the tests themselves, Kselftest and KUnit. And they represent two really different but totally complementary ways of thinking about quality. All right, first up is Kselftest. The best way to think about this one is that it tests the kernel from the outside looking in. And the key phrase to remember here is from user space. What that means is that kernel self-test works by running completely normal programs, just like any app on your computer. These programs talk to the kernel through its public doorways, things like system calls. This makes it perfect for what you'd call system testing. So if a developer adds a brand new feature, they'll write a Kselftest to prove that it actually works correctly from a user's point of view. It tests the whole thing from end to end. And now for the other side of the coin, KUnit. So if Kselftest is testing from the outside in, KUnit is its polar opposite. It tests the kernel from the inside out. This is where things get really interesting. KUnit tests are actually compiled into the kernel itself. This gives them like superpowers. They can call internal kernel functions and peek at data structures that are totally hidden from the outside world. This is what we call a white box approach. Now, if you've done any kind of software development, this idea of unit testing probably sounds pretty familiar. And it should. KUnit was inspired by really popular frameworks like Google Test or Python's unit test, but it was built from the ground up for the very unique, very challenging environment of the Linux kernel. So let's just put them side by side to make it super clear. Kernel self-tests, it's out in user space, doing black box testing on entire features. KUnit, it's inside the kernel, doing white box testing on tiny little pieces of code, like one single function. You absolutely need both. You need to know the individual Lego bricks are solid, and you need to know the whole castle stands up when you put it all together. Okay, so that's the theory. It all sounds great, but what does this actually look like for a developer who's, typing away on their keyboard? How do they run all this stuff? Well, for KUnit, there's this fantastic script called KUnit tool that just automates the entire process. It configures the kernel with the exact tests you want, it builds the whole thing, boots it up in a little virtual machine, and then it pulls out all the results and gives you a nice, clean summary. And this is the best part. All of that complexity, the configuring, the building, the executing, the parsing, it all gets boiled down to one single command. This makes running tests ridiculously fast and easy, which means developers are way more likely to do it all the time. And Kselftest is just as elegant. Once your kernel is built, you can build and run that whole suite of user space tests with another super simple command.
It's all about making comprehensive testing as frictionless as possible. That's the goal.
And this whole testing ecosystem, it's not just sitting still, it's always evolving. A perfect example of this is how it's integrating modern programming languages, like Rust, which brings its own powerful testing ideas right into the kernel's world. Take a look at this. This is a standard piece of Rust documentation for a function. But see that little code example inside the comment? The part that says assert underscore equal? Yeah, that's not just an example. And this is just, it's magic. The build system automatically finds those little examples in the documentation and turns them into real runnable KUnit tests. Just think about that for a second. It means your examples can never be wrong or out of date because your documentation is your test suite. It's a brilliant way to guarantee quality in a project of this size. So, when you bring it all together, what you have is this incredible combination of strategies. The high-level Kselftests act like a guardrail, making sure public features don't break. At the same time, the low-level KUnit tests are catching bugs deep in the code. Together, they create this amazing safety net that allows thousands of developers to work on this critical project with confidence. And it really leaves you with this one big idea. We talk a lot about trusting technology, but what we're really trusting is the process of testing, of verifying, of collaboration. Because when over 1 billion devices all depend on a single code base, that trust isn't just a nice feature to have, it's everything.